Well, thank you so much, Lynn. I'm not sure about rock star part, but I do know who are the rock stars this week. It would be the General Chair, Tao, and Lynn. And I want to thank all of you. We all know how hard it is to pull off the first inaugural session of a brand new event like this, bringing industry, academia, government from around the world together. And there is tremendous amount of hard work that the team has put in, and the two of you especially. So I really want to say thank you to start the day. And well, I think the slide before this one said, wake up in the fog. I have to tell you, my mind is a bit foggy. I'm not sure if I'm fully awake. And thank you for waking up so early on day 3. You may have had a lot of celebration last night, trick-or-treating in the fog. And waking up in the morning is not easy. So I'm going to try to keep my talk on 3 main points. So if you can, at the end of the talk at 9 o'clock, wake up. And people say, what did you dream about in the fog? And they say, well, I kind of vaguely remember 3 points. Then I'll be very happy. All right. So point number 1 is you need to donate money. No, actually, to Open Fog Consortium, which is a nonprofit organization. And as the academic co-founder, I remember 2 years ago, this very month in November, that we talked about launching the organization, and is immensely gratifying to see the signature event now, almost 2 years later, staged here. Well, the point number 1 is, what is fog? And point number 2 is, why do I care? And number 3 is, opportunities for you. Well, the theme is, we know cloud, and here's a guess that the cloud is descending to be among us, and the rise of the fog is inevitable in the next 15 years and beyond. Cloud is here to stay, and fog is rising to complement that. The future is foggy. That is the proposition. But what is fog? Well, there are different definitions. The one that I've been using since day 0, day -1, is fog is an architecture. So it's about the way that we divide and conquer, the way that we decompose the jobs that use either client devices or things in our body, around our body, or the edge devices for a variety of things, computation and storage and communication and control, and distribute these services immersively along a continuum that I call the C to T continuum, the cloud to things continuum. So I'll rather not draw a boundary and say that to the left is fog and to the right is cloud, although you see some visual like that in a minute. But that really is only part of the story. The full story is that fog is about that continuum. The continuum includes the cloud, includes the edge, and includes things beyond the edge, within our body. And as you can tell from my title, that it was almost a decade ago that I founded the Princeton Edge Lab. And I think that was the world's first lab devoted to edge computing and edge networking. And over the past few years, I've started using the word fog a lot more, and certainly in founding, co-founding the Open Fog Consortium, fog has been my favorite word. Right? So what is the relationship between these two words? Now I figure there's nothing more effective to put you back to sleep than to talk about the definitions. So let's do that. Now some of you is already falling asleep. Well, in my mind, fog is a superset of edge. So their relationship is almost like the relationship between fruit and apple. So people say, are you for fog, are you for edge? And I'm like, just say fog/edge if you want. I'm not married to one of these two words. I love both. But if you have to say, so what exactly is the relationship? I say, look, we have a word called apple to denote a certain kind of objects. This is the green one shown there. You've got red ones and so on. But then we also got a word called fruit. The fact that we already have an English word apple doesn't mean we shouldn't have the word fruit, because fruit is a broader class of objects that includes apple as a very important one, the one that keeps you away from doctor if you take it once a day. But there are other kinds of interesting subset of fruit as well, and similarly, there are other interesting subsets of fog, for example. If you look at a group of drones working with each other in the air, let's say, this is a particular project back at Princeton, where they collaborate with each other to enable the best 3D rendering in real time of what's happening on the ground. Okay? Now, do you call that a group of drones an edge network? Well, I don't know, it's the edge of what, right? It's just working with each other, helping each other. And certainly, that physical proximity collaboration is a main pillar of what fog stands for, even though you might not even want to call that edge. And similarly, a lot of embedded AI applications, that community doesn't come from the telecom traditional community that some of us are very familiar with. And they'll say, I don't know what is an edge and what is the core. All I know is that I'm doing some computation very close to the sensors and the actuators. So in my mind, we like apple and we like fruit. We like edge and we think of fog as a superset of that. And there are many types of these, whether you call it edge or clients or things, that's all around us, and contrast them with the ginormous objects like the one below. These are some kind of a server rack in the data center. And you can imagine also other type of big objects, whether it is a big gateway or is a big storage. And they are indeed so heavy that you cannot lift them with your two hands. Whereas the little things up there are the things that you can just pick up and go, right? There's a physical visualization that differentiates between the kind of edge and client things that we're looking at. And they are increasingly becoming more powerful, potentially mobile, doesn't have to be, but still with limited capacities in many other things. What is even more interesting is when you have a crowd of these edge or client or things that are dense, that are immersive, that are under-organized, they present tremendous interesting opportunities. For example, think of the set-top box at your home. You may not remember you still are paying $10 a month on average to your service provider for that useless piece of equipment sitting as a decoration on your coffee table. So the set-top box, what if that replaces the deep inspection box? So the privacy intrusion is mitigated. What if the dashboard caches the content from the cloud and store locally? What if your phones and the phones of your neighbors collectively become a PCRF? This is one of the traditional LTE evolvable cores functions, so that they can collectively do measurements and do counting and do pricing. There's a lot of these interesting opportunities, and the traditional view is that all of these things, the things that we wear, the things that talk to the core, the things that don't directly talk to the core, all of these things, they use, obviously, the data centers, the core network, and wide area IP connectivity. This view is still true, but now there's a newer view, the foggy view, and that is they are actually your cloud now. Okay? They are the core network. They are the IP backbone among themselves, and they are the data centers. Now, how many fogs are there? Also, this is an interesting question. We actually had some discussion. Shall we call it, fog computing, fog networking, or fog storage, fog control? And I'll say all of them. But it's a kind of a mouthful to every time you say, fog computing, networking, storage, control, right? Say that fast 5 times in the morning. So you know what? We could call it fog computing. But really, it's more than just computation, right? It is about the way that we communicate, the way that we store, the way we analyze, the way we control physical objects using cyber technologies. So for example, if you think of fog as a network architecture, now usually there are two kinds of planes in a network architecture, a data plane and a control plane. And you think of the 5 or 7 layer stack in a network architecture. Think of what Bob Kahn and Mincerf did in 1974 with the invention of TCP/IP, originally as 1 layer and then later split into 2 layers, right? The transport layer, layer 4, and the IP layer, layer 3. Those are very powerful architectural statements that says that certain modules will take care of certain jobs. And the job of the CEO is to divide and conquer and tell them who should be doing what, at what time scale, and how to glue them back together, right? It is the essence of architecture. It's not about resource allocation, it's about job allocation. And then you ask the CEO, so how exactly do you run your sales organization? And she'll say, I don't know, go talk to the VP of sales. You ask her, how do you exactly debug that device of product that you have? And say, I don't know. You ask the VP for engineering, right? In some sense, the CEO, are there CEOs in the audience? I hope not, because what I'm going to say is that the CEO is like the receptionist, right? His or her job is to just dial people to different places. Now, one thing, however, that CEO does is to think of the initial division of labor and continuously monitor the interfaces among them. Right? So it's a little bit more than just telling them which extension to dial. And similarly, architecture in network or in computation is like that. Right? That's what MapReduce is about. That's what TCP/IP is about. So if you think about the fog as such an architecture, then there are applications on top of it. So again, people ask me, how do you differentiate between fog and IoT? And I say, well, that's very easy, right? It's like, how do I differentiate between strawberry and smoothie, right? And the strawberry can be used to produce smoothie, but strawberry can also be used to make salad or whatever you would like to do with it, right? And similarly, fog can enable all kinds of applications. IoT is certainly one of them. And 5G and cellular is another one of them. And embedding artificial intelligence among the local ambience for big data, that's yet another main bucket of applications. Now, moving on to the second point. Now, what was the first point? The first point is on my own idiosyncratic definition of fog and how that differentiates from other words such as IoT or edge in different ways. Now, the second point is, why do I care? Now, part of the reason that I care is just because, well, I've been involved in the research in fog/edge since day 0. But why would, say, somebody from the business world care? Say, I've got cloud. Why do I still need fog? And that's a very legit question. What are some of the business values that can be unlocked by fog? I can think of enabling new services that require low latency, broadening the revenue basis as a result of such new services, and with the agility of fog development, accelerate the cycles, reduce the cost, in some case, because you are pushing things closer, if not inside the end users, to improve compliance. So I want to quickly run through 3 case studies. And some of you have heard me talk about these already, so please bear with me. And the first one is the application that's already deployed by a startup company that I co-founded called DataMi. You can check this company out. I'll save the commercial for DataMi for another day. Since DataMi is not officially a financial sponsor to the event. But what this company does is what we call smart data pricing. It enables things like flexible zero rating. Okay. Now there are 35 million users around 6 continents, mostly developing countries, where they still have to pay based on how much they use their LTE data quota. And this will allow them to do a variety of things, including a very intelligent way to do zero rating. Now, the point is not about pricing. I merely want to point out this as an example to illustrate that in the architecture for DataMi, we've got the client devices, like what I'm holding right now. Okay? We've got SDKs inside. It's got an over-the-top communication with an over-the-top pricing system that sits inside one kind of cloud, the Amazon kind of cloud as the controller. Does not sit into the traditional, you see on the right-hand side here, the LTE or 3GPP, generally whichever generation's core network. The traditional view is that if you want to do pricing and control and policy, you have to do it in here. Now we say, no, you can do it in here. You can do counting, you can do billing, you can do measurements, you can do crowd sensing of the inference of the network conditions, all with a bunch of client devices. They are coordinated, however, through a controller. And this controller sits in another kind of cloud, not the traditional one. So in other words, we still need the cloud, a different cloud, that runs the controller to do coordination. But the actual real-time crowd sensing of the network congestion and the byte counting to enable differentiated pricing are all carried out by the clients. Another example is to think about HetNets. And this is in collaboration with Intel labs and standardization bodies like 3GPP. Now think of the different lanes on the highway. One could be Wi-Fi, one could be the cellular, one could be the small cells. And as one single client, you've got choices they have to make. Right? Which lane should I drive on? Now there are two philosophies. One says you don't get to decide. Right? The government will tell you what to do. In this case, the cloud, some controller out there will tell you what to do. Now, the trouble with that is, A, the latency. In measuring the network condition, which lane is better for you to be on, others to be on, and B, incentives. Why would, for example, AT&T be incentivized to direct traffic to Boingo? So the other philosophy says, well, let the end users decide for themselves. Okay? They measure locally, and they make decisions locally. So this is an autonomous management based on their own inference for their own configurations. Now, the challenge, as you can see, or driving on the highways on 101, is a lot of drivers are too aggressive. They always think the other lane is moving faster, whether that's true or not. So they got a faulty local inference engine, and then they always would like to just switch lane, and then they slow everybody down. So how can we use mechanisms like randomization, hysteresis, that we worked out together with Intel labs to improve the stability and the efficiency of this autonomous decision-making process? And that's what we did. And interestingly enough, what we saw is that we still need the cloud. In this case, we have some long time scale parameter update that's given to the end user devices, who then run the actual real-time HetNets selection. Third and last example, okay. Shred and spread. This now actually has a beta rollout in another startup company, and we've got now some very large enterprise customers. The idea is that you've got some files you want to store in the cloud, public storage, and then you are worried that they will be hacked, and you hear the news all the time, despite all the encryptions that they're supposed to have secured the content. And what this does is to add a shim layer on your end user device, okay, in the fog, that would then shred your information into tiny pieces and then do some coding and other proprietary technologies to it, and then spread it over multiple public cloud. So even if one of them is hacked, all they got is perhaps the high-frequency components of your nodes. All right? And even celebrities may not mind getting that leaked out. And then when you need it, you're going to grab a subset of these from out there, whichever can give you the better response, and then in real time reconstruct on your end user devices. Again, without the kind of connectivity and computation we have now in our end user devices, this would not have been feasible in the past. So you can see that the privacy control is on the fog side, and the affordable storage at scale still happens in the cloud. And that is the spirit, that this is not a debate between cloud and fog. This is a collaboration that involves both. Anytime you need massive storage, heavy-duty computation, global coordination, you go to the click side. Anytime you need real-time processing, rapid innovation, and client-centric, you go to the brick side. And that brings me to the third point. Not only you should care about what fog can do for you. We have seen in just 3 quick cases, and these are university research projects rolling out into products and standards. And I'm not doing justice to all the outstanding work out there by companies large and small that are already rolling out fog-based products today. But also, there's an underlying reason why fog is uniquely enabling brand new revenue opportunities. Because it's about the scale. It's actually not, well, it's actually about scalability as well, but well, scale here stands for 5 unique features about fog, things that you don't have in the cloud. Now, one is security in the sense that by reducing the physical distance of information transmission, you also enhance the opportunity of privacy protection. And by putting some of the privacy control in the hands of the end users, you also help with that. C is for cognition, that you are aware in the fog of the client-centric objectives to enable autonomy. Now, A is for agility, because we're dealing with development systems and ecosystems, environments like this. We can have rapid innovation and affordable scaling. L is latency. Latency good for 2 things. One, real-time processing of data, what they call stream mining, rather than just data mining. As the data streaming in, and enables feedback control in what they call cyber-physical system, like connected autonomous vehicles. These are cyber-physical systems that are bundled together, and you need to have feedback control loop. If you have taken a course in feedback control back in college days, you might remember how important it is to have small and almost deterministic latency. 0 or very little variation in the latency from time to time. And E is for efficiency. You can do dynamic pooling of local unused resources, computing and connectivity resources. SCALE, scale. These are the 5 unique advantages offered by fog. And yet, we still got work to do, and that's exciting. That's why we are here. That's why Open Fog Consortium was founded, because we still don't really have that architecture, that decomposition and recomposition yet. I mean, you've seen the technical specification coming out from the consortium. You've seen a lot of exciting work the past 2 days in bringing those specifications and open reference architectures into standards and products. We've got a lot of work to do, and we can think about dispersing computation into this new substrate. And for example, this substrate, the foggy one, is heterogeneous in the OS, in the capabilities. It is mobile and volatile. It is constrained by the battery and bandwidth. That's so different from what you have on the racks of a fiber-connected, homogeneous cloud computing. So what kind of map-reduce decomposition would we have to map computation into the new substrate? We need to define the interface between the fogs and between fog and cloud. We saw some case studies just now. We need both software and hardware innovation. We need both cyber and the physical innovations. For example, there's tremendous opportunity to embed big data and AI into the cyber-physical systems enabled by fog. With stream mining and with the small deterministic latency that fog affords, if you can have that kind of right map-reduce infrastructure to disperse computation among the end points, then you got the tremendous opportunity to enable new AI services that are not imaginable today. You've got my email over there, and if I don't see you before the next Fog World Congress, and I want to tell you that it's not too late to join the Open Fog Consortium. Then we get together 3 times a year in addition to this wonderful event. I do hope to see you next year around the same time, perhaps right here in the Bay Area again with the 2nd Fog World Congress. But one thing I do know very much is fog is rising, just like cloud did 10, 15 years ago. And if you feel that I wish I could have done more 10, 15 years ago, well, this is your second chance. The second chance of fog is even better than cloud. Thank you very much. Thank you.